Hello, 7th graders. Mr. Gratchik here. Today we're going to be exploring the ideas behind what is potential energy. We'll be looking at two different variables that affect potential energy, mass and height. So, let's take a look at how we set up this experiment. The very first thing that we're going to do is we are going to find the mass of our marbles that we're going to be using in today's lab. We are going to be using a glass marble and a steely marble. And we'll set those on our electronic balance to find our mass. Remember, we're going to re-zero that balance. And the first thing that we're going to do is we're going to find the mass of the glass marble. And we'll record that as 5.3 grams. Our steely marble has a much larger mass. We'll call that 28.3 grams. Now that you've found the mass of your marble in grams, we need to convert the mass of our marble in grams into kilograms. To do this, we will divide by 1,000. Put that into your calculator and you will find that your number gets to be very small. We are only going to keep this number to the nearest thousandths. That's 3 places past the decimal. The second most important variable that we're going to be measuring while calculating potential energy is height of the ramp. We are going to be measuring the height of our ramp in 2 locations. The first location is the center of the ramp, and the second location is at the top of the ramp. The height of the ramp in the middle position is
3.5 centimeters.
And the height of the ramp at the top is
7 centimeters.
Please record that on your data table. The next thing that we're going to do is we are going to use our glass marble, and we are going to release that marble 3 times from the center of the ramp. We're going to get a measurement of how far this marble pushes this cup. So, first trial, 10 centimeters. Record that number, 10 centimeters. Second trial, 10 centimeters. Record that number. Trial number 3, 10 centimeters. Rolling from the same glass marble, rolling from the top of the ramp 3 times. 18 centimeters. 21 centimeters. 20 centimeters. The next thing that we're going to do is we're going to repeat the same experiment with the steely marble from halfway up the ramp. That rolled quite a bit farther, 56 centimeters. Trial 2, halfway up the ramp, steely marble, 57 centimeters. Trial 3, steely marble, halfway up the ramp, 58 centimeters. Now we're going to use the steely marble from the top of the ramp and do 3 more trials. "91 centimeters. Trial 2, 89 centimeters. Trial 3, 93 centimeters. Record that in your data table. Now that we've done the experiment, we are going to average our data. To average your data, you use a calculator, and you're going to take the 3 numbers from each of the trials, add them together, 10 plus 10 plus 10, hit equals, and then divide that by the number of trials, which happens to be 3. We'll record that data right here and continue on. Try that for our next 3, 1, 2, 3 trials. The last step of our lab is to calculate the potential energy. We're going to use the formula mass times gravity times height. Notice that mass is in kilograms. So in order to get our mass in kilograms, we're going to use our information found over here. Starting with the glass marble. The glass marble is 0.005 kilograms. And we're looking for the glass marble in 2 places, 0.005 kilograms. We're now going to write down the mass of our Steely marble. So I get that information from here, 0.028, 0.028, and that rounds out the mass portion of our project. Gravity is a constant. It'll be 9.8 for all of our trials. Will always be 9.8. And the last one we're going to use is height. We found the height at 4 different locations, or for 4 different scenarios. The glass marble halfway up the ramp. So we're going with the glass marble halfway up the ramp. That was 10 centimeters. The glass marble at the top of the ramp, that was 19.6 centimeters. The Steely marble halfway up the ramp was 57 centimeters. And the Steely marble at the top, of the ramp can be found here. This was in centimeters. To convert it to meters, I will just need to move the decimal point 2 places to the right. So that will be 0.1 meters. This will be 0.19 meters. This is 2 places to the left. That's 0.57 meters, 91.91 meters. Now, in order to complete this, you're going to multiply these 3 numbers across to get the amount of energy. Multiply across to get the amount of energy. Multiply this one across, hit equals. Multiply this one across, let's multiply. Hit equals. And you'll notice in our example, we only went 4 places past the decimal. Please keep your decimal points and your digits all lined up so that we can compare these. All right, you've reached the end of your potential energy lab. You've done some calculations using mass times gravity times height. There are 5 conclusion questions on the following pages. Let me know if you have any questions. Thanks for watching.